I'm Colin Bodwin, and I did my project on Petri-Nets. But before we get into this, here's a quick intro into program analysis. Why is this important to do? It helps shrink the communication barrier between developers and the business side of a company. It also helps simplify the overall idea of a system, and it can provide much needed documentation. There are a few different ways to do this. We can do this using decision tables, natural language requirements, finite state machines, Petri-Nets, and many others. So let's go deeper into Petri-Nets. Here are a few pros. The Petri-Nets offer us a clean overview of the system. It also doesn't rely on any previous system knowledge for the readers. And the system does become easier to modify or simplify when we have a different way to look at it. The con from this is it's quite labor intensive to create the Petri-Nets. It's not always clean, and the documentation can grow exponentially as the system continues to grow. So what was analyzed? I went with the triangle code that was given to me in a previous semester. There are 4 results that can occur from this code: an invalid input, an isosceles triangle, a scalene triangle, or an equilateral triangle. So what's wrong with relying on code analysis? As the system continues to grow, this code analysis becomes exponentially harder to do. And as new developers come in, it becomes harder and harder to explain the system. And with the loss of old developers, there's a loss of system knowledge. In other cases such as the COVID crisis with COBOL in states like New Jersey and New York, where they are relying on a dead language. This leads to the question about what about non-developers who have no understanding of programming at all? So what can we do to help these situations? I went with designing a Petri-Net. So a quick description of what I did before we get into this. I used a tool called SmartDraw to help create the Petri-Nets. And as opposed to the traditional tokens that you would use with Petri-Nets, I went with the actual input values. This helped keep the document clean, and it becomes a little bit easier to read for the followers. I then also broke down the Petri-Net into 3 distinct sections for reading. So why was this important to do a Petri-Net? It helps us give a visual aspect to this complex system. It removes reliance on programming and math, and it also helps with any future additions that we may want to make to the system. For this analysis, I went with an isosceles triangle as it must fail all the other cases to be deemed an isosceles triangle. First, let's go with the right side of the triangle. I was given the inputs 5, 5, and 3. We will take those inputs, transition them to these new places that will be used for the calculation to check if it is in fact a triangle here. This is done by comparing if A is less than B plus C, B is less than A plus C, and C is less than A plus B. As we can see, this is true, and we have a result of 3 that comes from here. Now we will go to the left side. We will again take those inputs of 5, 5, and 3, and we will transition them to these new places. Our first thing that we will do, we will check if all 3 sides are equal. 5, 5, and 3 are clearly not equal, so this case fails down here. Next thing that we're going to do, we're going to check that A is not equal to B, A is not equal to C, and B is not equal to C. First, we will go with A not equal to B. But 5 and 5 are equal, so we again fail this situation, as we can see here. So now we can go to the bottom part of the Petri-Net. Here we check again the previous inputs of the previous outputs of the left and right side. As we can see, we have the 3 value. This means that this cannot be invalid as there are values here. And we can see that A, B, and C are not equal. 5, 5, and 3 are not equal. And we can see A not equals to B, A not equals to C, and B not equals to C also fails. So this means the triangle cannot be equilateral or scalene, resulting in the fact that the triangle is an isosceles triangle. This results in this document. This has all the inputs and results that we have just discussed. As we can see, this has grown to be quite a complex system to look at, but is a lot easier to understand as it does not rely on any language and it removes most of the complex math.